All right, welcome back from vacation. This is Mr. Hendrickson with lesson 9-7. We are taking over from in Algebra 1, Volume 2, graphing quadratic functions from standard form. Today's lesson will just be a review because I know you had a week off. So we're going back and reviewing how to graph quadratics in standard form. So again, standard form is the important part here. The steps are written out here, so this should help you review as well. So step 1, find the equation for the axis of symmetry. And I'm going to write the equation up here next to it. X equals minus b over 2a. Now, remember, and that means we need to know what a, b, and c are. So when you do this problem, it helps if you start by labeling what a, b, and c are. So I'm going to start the problem and put a equals the number of x squared you have, which in this case is 1. The b is the number of x's, which is 4. And the c is the number at the end, which is just 3. So to find the axis of symmetry equation, we actually do this. X equals minus b, so in this case minus 4, over 2 times a, so 2 times 1 is just 2, which is negative 2. So the x value is negative 2. If we want, we can come over to the graph now and put in that axis of symmetry. Second step is to find the vertex and determine whether it's a max or min. So the vertex is we already have the x value. Now we just have to find the y value that goes with that. So I go back to my original equation, and this f of x, that's what stands for y. So I'm going to plug in my x value into this equation to find the y value. So y equals, my x that I have here is negative 2, so I'm going to put negative 2 squared plus 4 times negative 2 plus 3. And negative 2 squared is positive 4. 4 times negative 2 is minus 8 and plus 3. So 4 minus 8 plus 3 is negative 1. So my vertex turns out to be the point minus 2 minus 1, and that's the vertex. So it helps now if I go over to the graph and find the point minus 2 minus 1 and put that point. From last week, well, the week before possibly, we wanted to find out if that's a maximum or minimum. And if you recall, that's based on this a. If a is positive, it's a normal facing parabola, which means it's going to go this way because a is positive. If a was negative, it goes upside down, which tells me this is going to be a minimum. So that's going to be the bottom of my graph. So my parabola is going to go this way. Now, I just need to find out what the y-intercept. The y-intercept is fairly straightforward in standard form. The y-intercept equals the c value. So we just get y equals 3. And that's because for the y-intercept, the x values are 0. So all the other parts become 0. So that's 0 plus 0, and you just get the plus c part, which is 3. So at y equals 3, if I put a point there, I know this is the bottom of my parabola, and it goes up smoothly to hit that point. And then the next thing is use symmetry to find another point. If this went over 2 and up 4, I can go over 2 and up 4 on this side and get another point on that side to connect. And then you can draw your parabola. Sometimes it helps to label that point because I know I have this point being 0, 3. This one now I can say is also minus 4, 3. But that's how I get all my points. So if you follow those steps one at a time, you should be able to get all the key points and lines to draw your parabola. So we'll go through one more example here, example 2. So this one has, again, I want to find the equation, the axis of symmetry. So I need to start by labeling my a. In this case, it's negative 2, so be careful there. My b is the middle number, and my c is negative 1. Be careful if they're missing a term to make sure you still label the a, b, and c. Sometimes they don't have an x term in the middle. That means the b is 0. Sometimes there's no number, and the c could be 0. So you'll have to be careful about some of those things. For the axis of symmetry now, I get my minus b over 2a. The minus b makes that negative 2. 2 times a, so I got to be careful because 2 times negative 2, so make sure you get negative 4 there. And negative 2 divided by negative 4 gives me a positive 1/2. So that's what the x equals, positive 1/2. So you got to be a little bit careful on that one. That means my axis of symmetry is at a half. Makes the math a little bit trickier because I'm using fractions. For some of you, I know if you have a calculator, sometimes it helps to turn that into 0.5. Because then I need to find the vertex, which gives me the y value that goes with that. So I need to do negative 2 times, now the x being squared, I like to use the fractions, but if you use a decimal, that's fine. But it's, oh, that's 1/2 squared plus 2 times 1/2 minus 1. Now 1/2 squared means I do 1/2 times 1/2, which is 1/4. So minus 2 times 1/4 is minus 2/4, which really comes out to be minus a half, but I'll get to that. 2 times a half is plus 1, and then minus 1. Those are going to cancel, so I just get the y value equals minus a half. So I can do my vertex as the x value is 1/2, the y value is minus a half. So if I go over a half and down a half, my vertex is going to be kind of in the middle there, a little bit trickier to get. I also want to know if that's a minimum or maximum. Because my a value is negative, that tells me this is one of the parabolas that goes upside down. So that's going to be a max. The y-intercept equals c. So I get y equals, I look at my c value, which was negative 1. So I can go on the y line. And that's, again, the x value is 0. And then it's really close to it there, but I know my parabola is going this way. To get another point on the other side of this, I go over to that, and I can draw my parabola that way. And I like to label that other point sometimes. If this one is, this point here is 0, negative 1. So sometimes if I put that one, 0, negative 1. This other one was 1, negative 1 for my last point, just so I get an indication of that point. Eventually, it helps to do a whole XY table and get more points, but those are the key things. You only need those in order to get the parabola. So good luck. The back of the paper, or the second page, is your assignment to finish from there. Good luck and have fun. Welcome back.
We're quite a team.
Didn't stop yet.